Parabolas. There are two basic forms that you can see a parabola in. There's standard form, which is the y equals ax squared plus bx plus c form, and the vertex form. Now in either one of these forms, in order to graph the parabola, the two pieces of information you would need are the axis of symmetry, the vertex, and the stretch. What's convenient is that whichever form that the parabola is written in, the a, or the coefficient of the x squared term, always represents the stretch. So a is always the stretch of the graph. What's really convenient about the vertex form is that you can read the coordinates of the vertex right up the graph. It's just the h and the k value from that that equation of the parabola, and the axis of symmetry is x equals this h value. So the axis of symmetry is always the vertical line through the x coordinate of the vertex. When it's in standard form, you could still read off this axis of symmetry. It's just hidden in those coefficients, and it's x equals negative b divided by 2a. So if you want the vertex for this standard form graph, you first find the axis of symmetry and then plug that value back in for x, and you'll be able to get the y coordinate. So first, let's look at a couple of examples here for identifying the vertex and stating whether or not it is a maximum point. Now, when you consider the graph of a parabola, it would be a maximum if the parabola is facing down. So that is when that a value is negative, you'll get a max. And if that a value is a positive number, this parabola will be opening upwards, and that vertex will be a min. So that's how you determine whether or not it's a maximum or a minimum value. So let's look at two of these examples, and then you can try two on your own. And I'll write the solutions down. But for this one, it's in vertex form. So I can read off the vertex. Will be at when x is -3 is the x coordinate, and y is +4. So it's the opposite sign for the x value, and it's the same sign for the y value. And since the a is greater than 0, this vertex is going to be since a is greater than 0, this will be a minimum because the graph will be opening upwards. For the second one, it's in standard form, so I'm going to use that equation for the axis of symmetry, negative b over 2a. In this case, since b is -6, negative 6 will be +6 over 2 times 1 is 2. So the x coordinate is 3. And to get that y coordinate, I'm going to plug 3 back into that equation, replacing x with the value 3. So it'll look like this. So 3 squared is 9. 3 times -6 can be -18. And then I have +1, so this is 9 minus 18 is -9, plus 1 is -8. So my vertex is at the point 3, -8. And since my a is 1 in this case, it's a positive 1, it's greater than 0, this will again be a minimum value. So my vertex is here, and it's a minimum. Graphing parabolas. When I graph parabolas, again, I need to locate those same values, so the vertex for this equation will be at 3, -1. Then I also need to identify the stretch, which in this case is 1. So when I go to graph this parabola, number 1, my vertex is over 3 units and down 1 unit here, and it has a normal stretch. Now recall, when we're graphing these parabolas, we'll use that 149 trick. So when I go over, I'll have to go up since it's a positive value, over 1, over 2, over 3, and then it'll be a times 1, a times 4, a times 9, and in this situation, since a is equal to 1, this is just equal to 1, 4, and 9. So I'll go over 1, up 1, over 2, up 4, over 3, up 9. That puts me off my graph, so I'm not going to plot that point. And then my axis of symmetry goes through that x coordinate of my vertex, and it's called an axis of symmetry because that graph is symmetric around it. So I'll have a symmetric point here, and I will have a symmetric point here, so it's acting kind of like a mirror. And then I go to sketch my graph. Okay, so this is y equals x minus 3 squared minus 1. Now I'll plot my other graph. Again, I need my vertex, so first I'll find my axis of symmetry. It's -4 over 2 times -2, which will occur at -4 over -4, or 1. Plug that value in to get the y value, so this will be negative 2 times 1 squared, which is 1, plus 4 times 1 plus 3. Give me 1. So it looks like my vertex, wait, I'm sorry, that is actually 5. So that means my vertex is at 1, 5, which is here. In this case, my graph is negative, so it'll be down. So I'm going to go over and down. So I'll go over 1, 2, 3. I'll go down a times negative 1, a times negative 4, and a times negative 9, which in this case is negative 2. This is negative 8, and this is negative 18. So from here, I go over 1, down 2, over 2, down 8. That's 2, 4, 6, 8. And over 2, down 18 will be too far for this graph. I'll plot my symmetric points, and I'm going to scroll down so I can get a better view of this graph. And I'll plot my parabola. Okay, turning point, coming back down. A little bit hard to draw on the computer, but there we go. So there are my two parabolas. I should label this one, which is negative 2x squared plus 4x plus 3. This is y equals negative 2x squared plus 4x plus 3.